Hey guys, welcome back. 9-2 changes of state notes. Go ahead and write these down over on the left. Go ahead and write types of changes. And when we are talking about changes of state, what you guys all need to know is that anytime we have a change of state, it's simply considered a physical change. We're just physically changing it is all we're doing from one state of matter to the other. We're not changing it in anything new, which is why it's only considered physical. Now there are 6 changes of state that you guys are going to learn in this chapter. 1 is melting, 2 is freezing, 3 is vaporization, and this will include evaporation and boiling, which we'll talk about in a little bit. 4, condensation, 5, sublimation, which is new, and 6, deposition, which is new to you guys. This pyramid a lot of times will help students remember them. So when you go from a liquid to a gas, we have vaporization. When we have gas to a liquid, it's condensation. Freezing is liquid to solid. Solid to liquid is melting. And then solid to gas is going to be sublimation, where gas back to a solid is deposition. Notice the colors. Red indicates that heat or energy is being added to the system. Blue indicates that heat or energy is being taken away. Alright, so let's head down here to melting. Melting, as you already know, is going from a solid to a liquid. Energy is being added, or heat is being added to the system. It melts, or water melts, at 0 degrees Celsius. The melting point is the same as the freezing point. So if we're actually adding heat to the system at 0 degrees, it's melting. But it's the opposite when we get to freezing, which is going from a liquid to a solid. Energy or heat is being taken away, taken out of the system. And we freeze, water freezes at 0 degrees Celsius. And that's simply because we're taking heat away now, and that's why the freezing point is the same as the melting point in this case, because heat is taken away. Now we get to vaporization. It is going from a liquid to a gas. Heat or energy is being added to the system again. We know that water boils at 100 degrees Celsius. Now vaporization is simply when we're boiling and evaporating at the same time. Evaporation occurs only at the surface of a liquid. Now we'll go ahead and pull up some pictures here so you can see that. Let's see, vaporization first. This includes boiling and evaporation. So the water's boiling throughout the liquid, and we also have evaporation occurring up here in the surface. Evaporation, though, is a little bit different. We'll go ahead and pull that picture up. We'll go ahead and move this over a little bit so you can see that. Evaporation just takes place at the surface of the liquid. It doesn't happen down here at all, just at the surface, which is why you see that puddle of water after a rain on the sidewalk go away so quickly, because it's just happening at the surface. The water vapor is leaving. Okay, so we'll go ahead and close out of that. Bring our notes back down here to where we were before. Alrighty. Alright, so what is condensation now? Condensation is where we're going from a gas back to a liquid. Energy is actually being taken away. An example includes droplets on the outside of cold glass. If you've ever gotten a glass of pop or water in the summertime, you put it on the counter, you come back a few minutes later, guess what? No, the glass isn't leaking, but water is actually formed on the outside, and that's because the gas, the molecules that are moving so fast on the outside of the glass, as they come near the glass, they slow down so quickly that they jump from a gas back to a liquid, and they form smack dab right on the outside of that cold glass. And here is a good example. We can see the window. Definitely the liquid has formed. As the gas gets close to it, it gets very slow and then converts right back to a liquid state, which is what you're seeing. And that's when we can have some fun and write on the window. Next, we get to something called sublimation. Now this is new. Sublimation is where you go from a solid, you jump the liquid state and get to a gas. We add so much energy or heat to the system that it skips the liquid state. Examples include things like dry ice, mothballs, and those solid air fresheners that mom might put on the back of the toilet that slowly just get smaller and smaller over the month. That's sublimation. It's going from a solid to a gas. And again, we'll click here for an example. There's some dry ice that you see. There's a solid. We skip the liquid and go right to a gas that you're seeing right there. So much heat energy is being added that it skips the liquid state. Alright, last but not least is what we call deposition. Deposition is the opposite of sublimation. It's going from the gas back to a solid. So heat or energy is quickly being taken away, and since we do that so quickly, we skip the liquid state again. Deposition is when you see water vapor changing to ice. The best example is the frost that you see that forms on the trees. We saw a lot of this example last year in the winter time because it just so cold at night, and during the day we quickly froze and went from the gas back to a solid. Alright, so that's deposition. So think of it like ice depositing itself on items, so frost. Alright, as we get down here, we're talking about phase change versus temperature. So what does that mean to us? Well, what you need to remember is that temperature does not change until the phase change is officially completed. So the temperature will always remain constant, or fairly constant, within a half a degree or so, until the change is completed. And if you look here, you can see, think of this like ice. As we heat ice up, it melts, it melts, it melts. Alright, and then once it reaches 0 degrees, it's melting. And when that ice is completely gone, every little ounce of ice in your glass is completely gone, guess what? The temperature starts to rise. But while that ice is in there, still melting, even the smallest little chunk, the temperature is going to remain roughly 0 degrees Celsius, or within half a degree of that. But as soon as that chunk of ice is officially gone, guess what? You'll watch the temperature shoot right up as it's liquid, and it heats, it heats, it heats, and then when it hits boiling, guess what? It's going to start boiling and evaporating, and during that time that's boiling and evaporating, the temperature again will remain constant at roughly 100 degrees Celsius. And of course, since we're not at sea level, it's going to boil just a little below 100 degrees Celsius. But as soon as every little ounce of water is gone, it immediately will start to heat up beyond 100 degrees Celsius. Alright, so biggest thing to remember is that actually during that phase change, during the melting or freezing, or the actual boiling or condensing phases, the temperature will be a flat line and will remain roughly the same. Okay? And during those slanted areas that you see, temperature is either increasing or decreasing depending on which way you're going. Alright, well that pretty much ends our notes. You just have one final question to answer for me, and that is, which changes of state require energy to be added? So out of these changes that we just talked about up here, which ones require energy or heat to be added? Which ones require energy or heat to be lost? So go ahead and write that down. Alright, that ends our notes. We'll see you in class.